Hi, my name is Chengxi, 12 years old. For this lesson, we'll be continuing on with the techniques and applications for definite integration. For this lesson of definite integration, we have these two examples where we have to find the volume bounded. So for our first example, we have to find the volume bounded by the cylinder x squared plus y squared equals to 4 and the planes z equals to 0 and y plus j is equals to 4. So what we have here is that we have to find the volume, but just because we have to find the volume doesn't mean it have to be triple integration. So over here we have the z, the height, and then we have dx, dy being the area and all. So how do we find the boundaries? So you can clearly tell that 4 is 2 squared, so x squared plus y squared basically 2 squared. So over here for this part, when you want to integrate over here for this part, y is going to be from -2 to 2, while x is going to be from the two functions. So x squared is basically 4 minus y squared, so x is basically either negative square root 4 minus y squared or positive 4 minus y squared. Okay, so in this case, I am integrating with respect to x first. Well, for our first example, we can integrate with either x or y first. Okay. Hey, because over here what we have, so what is j equals to? So apparently j is equals to j is basically 4 minus y. That's why we can integrate with respect to either x or y first. Okay, now that we have gotten this part, we can integrate already, which we will get -2 to 2. For x from negative square root 4 minus y squared to square root 4 minus y squared dy. Then you minus over here, you have -2 to 2. And then for this part, y becomes xy from negative square root 4 minus y squared to square root 4 minus y squared dy. And now when we substitute these parts inside, what we're going to have is 4 from -2 to 2 square root 4 minus y squared, and then you plus, because there's a negative over here by the boundaries, and we also have another negative here, so negative become positive, and plus 4 minus y squared dy minus. So now that we have gotten this part, we are also going to have this part, which is y square root 4 minus y squared, minus for the boundaries, and the negative over here cancels out and becomes a plus y square root 4 minus y squared dy. So over here, apparently for this part, for now, since we have gotten 8 square root 4 minus y squared dy, we cannot solve it yet, right? Because you cannot just straight away integrate in this case. On the other hand, over here you can straight away integrate it. But first we have to put the y inside. So for this part, so when you put the y inside, it becomes a y square. And when it becomes a y square, the 2 would simply cancel out with the 2 needed for this y square over here. And because for this part we want these two to be similar, when we differentiate any form of constant, it will always become 0. So that's why we can put this here. And the negative, since we have a negative here, this is going to become a positive. So now that we have gotten this part, we can integrate it. On the other hand, for this, we can just make it stay the same for now. So apparently we have this to the power 1 over 2. So what we have over here, 4 minus y squared, 3 over 2 from negative 2 to 2. And then for this part, it will just be here. So this would be 2 over 3, whereas so for this part, we can straight away use substitution already, where we are going to let y be equal to, so since this is a minus and all, so we want to take out the 4 out and get the 2 outside, right? So we're going to have the 1 minus whatever it is. And since it is a minus, we're going to use, so for this part trigonometric substitution, we're going to use sine. 2 sine theta. And thus dy both sides differentiate becomes 2 cosine theta d theta. And then we have theta being equal to inverse sine y over 2. And then we are going to have theta's boundary as, so inverse sine y over 2. First we have negative 2 inverse sine negative 1. It's basically negative pi over 2. And inverse sine 1 is basically 2 pi over 2. And what do we have here now? So over here what we're going to have is, so you have a 2 taken out from the square root part, which is 16. Then you have another 2 from the dy. So you're going to have a 32 from negative 2 to 2 square root 1 minus sine square theta cosine theta d theta. Then for this part, if you substitute the 2 inside, it's going to, and since it's square, so it's going to be 4, it's going to end up with a 0. Well, for our second part, negative 2 squared will still be 4. So when you minus, it will be 0, thus we can ignore it, because it will just end up being a 0. Well, for this part over here, what is 1 minus sine squared theta? So 1 minus sine squared theta, what we'll have will be, so since sine squared theta plus cosine squared theta is equals to 1, so this part will have a cosine squared theta since it times over here, and we have the square root. And now that we have gotten this part, we are going to use the double angle formula. Which we are going to end up 1 plus cosine 2. Whoopsies. This is pi over 2 and negative pi over 2. And now that we've gotten this part, for our first part we can integrate and we'll get theta from negative pi over 2 to pi over 2. Then for our second part, we're going to have 8 instead, because if you want to integrate for this part, you're going to need another 2, so it's going to become 8 sine 2 theta from negative pi over 2 to pi over 2. So what we're going to have now over here is 16 times pi over 2. We have a negative from the boundaries and negative from here. So negative become positive and becomes pi over 2 plus pi over 2. While on the other hand, for this sine part, had the pi, so sine pi over 2 times 2 is basically sine pi, and here is sine negative pi, right? And since sine pi or negative pi, they are both equal to 0, so we can ignore it since it will just end up being 0. Well, here, what the result we get over here is 16 pi. So that'll be all for our first example, and now moving on to our next example. So first, take a quick look. Okay, moving on to our next example, we have to find the volume bounded by the paraboloid x squared plus y squared for y squared is equal to z and z is equal to 0, so y squared equals to x and x squared equals to y. So for our second example, we're going to use double integration again. So it's basically like how the integration works. So we have the z being the height, and then we have the dx dy being the area. So it's something like layer by layer and all. Okay. So for this part, what we have over here. So now that we have gotten this part, so apparently we can integrate with. You can choose which one you want to integrate with respect to, either x or y. Well, if you want to know what the boundary is, so first of all, for our first example, we can just straight up draw a circle, while on the other hand, for our second example, we are going to need more than just a circle. So first we have the y squared equals to x, where, well, for this example, we're going to integrate with y first. So I'm going to write all the function by writing the y equals to. So this is basically y equals to square root x. So y equals to square root x, and then we also have our y equals to x squared, which is and this is our area bounded, which we are going to stack up through the z, and we get the volume bounded. Okay. So for this part, what we're going to have over here is going to be, so for our, since we are integrating with respect to y first, we are going to move from down to up, which is in this case x squared to square root x. So x squared to square root x. Well, what about for our x? So it's basically x squared need to be equal to square root x, whereas our two cases are x is equal to 0 or x is equal to 1. Both are okay. So this part is basically the range over here. It goes from 0 to 1. And now that we have gotten this part, we can put in what z is. So I'm going to put dy first, since we are integrating with respect to y first. Then now we can integrate it, and we're going to get x squared y plus 4 over 3 y cubed from x squared to square root x dx. Okay. Then we're going to have, for this part from 0 to 1, when you substitute this part in, we're going to get x to the power of 3 over 2. Then when we sub this part in, you're going to minus the x to the power of 4. Then when you sub this part in for this part, we're going to have plus 4 over 3 y to the power, x to the power of 3 over 2. Then for this, when you sub it in, it's going to be minus 4 over 3 x to the power of 6 dx. So now that we have gotten this part, we can straight away integrate it, and we will get a x to the power of 5 over 2, and we'll have a 2 over 5 in front from 0 to 1. Then here we're going to get minus 1 over 5x to the power of 5 from 0 to 1. Then we have this part, which is going to become 2 over so this is supposedly a 5 over 2, and thus this will become a 7 over 2 and a 2 over 7. Okay. Whoopsie. So this will become a 5 over 2, and thus this way you have a 2 over 5 x to the power times 4 over 3 x to the power of 5 over 2. Then here you're going to minus 4 over 3 times 7 x to the power of 7, 0 to 1. Okay. Now that you have gotten for this part, we can substitute the boundary inside, and if you realize when you substitute 0 inside, you're just going to get 0. While on the other hand, if you substitute 1 inside, you're going to get 2 over 7 minus 1 over 5 plus 8 over 15 minus 4 over 21, which is equals to 3 over 7. Okay, so that is our result, and that will be all for this lesson. So for these two examples, you can choose whichever you choose, you can both use it, whether it's integrating with respect to x first or integrating with respect to y first. So for our first one, the x or y plane, or you can call it when the z is 0, or basically the area is basically a circle. While for our second example, we have this shape over here. Okay, so that'll be all for this lesson. Take a quick look. Last but not least, thank you for your watching.